Wonderful, wonderful. Oh, there we go. Okay, I'll just share my screen as is ceremonial. Cool. So let's move this to the Zoom bar. Oh, I can't do well. Okay, well, welcome everybody to the first drand code walkthrough. Today's session is going to be on the CLI. But before we move ahead, obviously, I think everyone here is signed up on Luma, but we've got all the future events you can sign up to. So if you're interested in any other sessions, of which there's a list down here, please sign up, get involved. Hopefully by the end of the full 8 sessions, everybody should be an absolute expert in drand and everything drand related. We started these code walkthroughs because a bunch of community members expressed an interest in participating in drand ecosystem, not just running a node, but also developing things and helping work on the code base. And it's quite a big code base at this stage. It's been around for 5 years or so. So it's quite complicated for an open source community member to just jump in and start contributing straight away. So hopefully after these 8 sessions, everyone will feel confident with the architecture, how to run a drand network, how to make changes to a drand network if you wanted to make your own custom fork and do some crazy things, or just help us fix bugs and extend what we've got at the moment. So yeah, please sign up on Luma, get involved. Excellent. So now to a rough agenda of today's walkthrough. We're going to start with the project structure, how it looks in your editor, as it were. Then we'll move on to installing drand. Then we'll go back to the code base a little bit and go through the command package, how it's laid out, how we create new CLI commands, and how the existing ones are implemented. Then we'll start actually running our own drand network. So we'll start by generating a key pair. Key pairs can underpin every other operation a drand node performs. Then we will start a daemon. After that, we'll actually start a couple of daemons and we'll run a distributed key generation process so that our mini network can start creating beacons. Also, by the way, feel free to play along, as it were. You can probably run all the commands in your own shell if you've got the right dependencies installed. After the DKG is done, that stands for distributed key generation, in case you didn't know. We'll have a look into the drand folder structure, i.e. the state that gets stored on a node when it's running, and kind of demystify some of the parts there. Then we will probably actually do stopping a daemon at the end, because first we'll look into some cool utilities that you can use on a running drand network to check its health, do some other things. Then if there's time, because that's quite a lot to go through already, we'll dive into some of the client libraries so that you can integrate with drand in your either application, web app, blockchain system, whatever you want to use. And then if we really still have time at the end, by some miracle, we'll look into running it with Docker. We provide some out-of-the-box config to spin up your own network locally, but we're going in raw for the first go, so you know how to actually run the commands rather than just spinning up some Docker images. Okay, so before we dive into the project structure, just a little overview of what it is to run a drand instance or a network. So there are a couple of different parts. The core one is this daemon here in the center. It is kind of the conduit for all the other commands and interacts with a bunch of other people's drand daemons that run in a network configuration. The daemon, by default, writes to a flat file database. So just basically a bunch of files on your file system that can pull things like the key pairs and the beacons from. Outside that, we've got a couple of other different binaries, which are sort of the same binary, but we'll see that in a moment. We've got a CLI, which operators can use to send commands to their nodes, either to do things or to check the state of the nodes. And we also have a set of relays. This box is a bit of a lie because there are multiple types of relay, but in essence, they sit in front of a drand daemon, allowing users to proxy requests for randomness without opening your daemon to the world, with some benefits like caching and some other things. This reverse proxy box is not part of the drand infrastructure per se, although basically everybody in the League of Entropy, i.e. the network that runs drand in production at the moment, or the consortium, nearly everybody runs a reverse proxy in front of it, which is useful for TLS termination and scaling and a whole bunch of other things. Okay, so that is the overall landscape that a drand daemon fits into. Let's jump over and have a look at the project structure here on the left-hand side. Fortunately, my screen's huge. This might be very small for some of you, and I can't zoom in on the file tree, so that is it's a shame. Get your magnifying glass out at the ready. So we have a whole bunch of different modules in here. The one we're going to be focusing on today is this CMD module. That's for the command line. A bunch of stuff then lives in the core and common directories. As you might expect, they contain a lot of the core bits and bobs that come together to make up a drand daemon or other parts. Also, we've got an internal package which encapsulates some stuff that we don't want the outside world to accidentally rely on. We had some instances in the past where people were using parts of the internal drand daemon, and then whenever we changed them, they had some issues with compatibility. Also, there's a client in here that is multi-purpose. It works not only for relays or contacting the original daemon, but also people who want to access the network from outside. Additionally, all the internal traffic is done over gRPC. That is Google's RPC framework that uses a data format called protobuf, where you can define a bunch of models and services to interact with those models over a network. And we've got some tests and a whole bunch of other stuff, but those are the kind of important ones. And I suppose crypto, obviously at its core, drand is a cryptographic network of sorts. So there are lots of cool crypto operations, which we will go into in other sessions. So I'm not going to look into them now. Okay, so to actually install drand, the first prerequisite as of very recently is Go 120. So if you're following along at home, you might want to install Go 120 now if you don't already have it. Everything else is kind of done through a make file. Make is kind of the oldest and frankly slightly horrible build tool, but it's supported everywhere and widely understood, well, with the right stack overflowing. Contributors might reasonably use linting and some other utilities here in the make file, as well as running a whole bunch of different tests with a lot of different configurations for setting up a node and testing it in different scenarios, like different storage backends and such. We're not going to look too much into that.
Patrick?
Oh, hello.
Can you maybe increase the size of the main view font? Yeah, that's much better.
That didn't work very effectively. Okay, maybe that's better. Okay.
Yeah.
Cool. The bit that's interesting to us today is the install and build commands or make routines. So the install will install to your local Go bin, where Go installs all kinds of fancy binaries that you use. And build will install it in the repo directory, so locally, essentially to where you're at. Okay, so I mean, as a bit of a demo of sorts, let's see if I can make this bigger. Ooh, wonderful. I'm in my drand repo here, so I'm just going to do a make build. And we'll see that the build artifact here should be something called drand. I've set up another directory that I'm going to do all the magic in. So I'm going to copy the drand binary into my drand test directory. Like this. Okay, wonderful. Now what we're going to do is look into the command package very quickly. So essentially what we build here is this CLI. It also encapsulates the binary. So when we run the start command, it's going to basically run that binary. Inside the command package, we can see there's actually a bunch of different command lines. We've got the different types of relay here, and you can also run just a client as a command line utility. We're going to be focused on the drand CLI, which I've conveniently opened here, although in rather small form. Let's see if, okay, wonderful. So we use a library called yourfav CLI, which My experience has not been my favorite CLI so far, but it does the job. In essence, you configure a bunch of flags and then you configure a bunch of actions that use those flags. So we have a absolute mountain of different flags here, which we'll go into as we use the commands, but we shan't labor on those just right now. Here we have the actual app commands. So the important one that we're about to use in a moment actually is generate key pair, which is down here. It takes a couple of different flags. The control flag, as I said before, all communication with the node is done using gRPC. So the control flag is the port that your daemon is going to run. It's going to run its control gRPC listener on, i.e. the one that uses CLI to send commands to. There's a folder flag, which is for configuring where your drand state is going to live. By default, it's in your home directory under .drand, but we'll see shortly. We'll use a slightly different. There's an insecure flag, which comes with many dragons. So we'll talk about that as we run a command. There's also a beacon ID flag. Since 1.4, drand supports running multiple beacons inside one instance. A beacon is essentially one instance of a drand network, a chain, if you will, although it's not quite a chain. Because we support different schemes for creating different types of randomness, you could be running multiple beacons that offer different schemes and different guarantees. Similarly, you could be running multiple networks with different participants depending on your security model. And as alluded to, there's also a scheme flag. Each key pair will have a different scheme and some different layout to the cryptographic material. So whenever we're generating a key pair, we can pass in different schemes to generate the right one. Okay, so let's generate a key pair then. I'll go back to my little drand test directory. Okay, so I have got 3 folders here. I've actually got 4 folders, but we're only going to use 3 because I've got 3 shells up. So we're going to set up 3 drand nodes, 1, 2, and 3, and we're going to generate a key pair for each of them. So we pass in the generate key pair command. Now, what might be useful before we do this, in fact, is to look at the output of the generate key pair command. So if we client 4, which I've done in the past, already has a key pair here. So let's look at the public key. So the public key consists of an address here. This is going to be how other nodes in the network connect to your node. So this isn't public to the internet per se, but should be a firewall to other nodes that are going to be in the network. It's important if you're using, for instance, a load balance or something else in front of your drand instance, that you're pointing to that and forwarding the traffic to the drand daemon, because other nodes are going to use this when they contact you, basically. Here's some key material in hex, no surprise there. Now, TLS equals false. This is where there be dragons in the CLI. Most of the CLI commands can take a TLS disable flag, which is important in some of them and dangerous on other of them. So if you were running this in production, the chances are you're going to terminate TLS somewhere, and you should, because that's good security practice. So it's important if you're contacting other nodes through, for instance, reverse proxy with TLS, that this is true whenever you're generating your key pair, or else they'll try and send plain text packets and things will get a little bit messed up. However, for today, because we're running it locally, we're going to be running it without TLS. So we're going to pass the TLS disable flag elsewhere. A point I'll come back to, but when starting the daemon, if we're running a live drand network and we've got TLS terminated somewhere, it's important that we pass TLS disable to the start command, because in days of yore, technically now, drand daemons supported TLS termination themselves. So you can provide a TLS cert to your drand daemon and it will do all the magic for you. Although, to my knowledge, nobody in the League of Entropy runs it that way. We don't run it that way. And we're planning to get rid of it because it's caused more pain than use, basically. So long story short, in the live network, generate your keys with TLS, run your daemon without TLS, do TLS somewhere else like Nginx or load balancer or something else. Also contained here is a signature of the public key. It's obviously important to know that people actually have access to their private key. And we've also got a scheme name here. Like I said before, drand supports multiple schemes, so it has to be with the key. Okay, great. That's all the preamble done. Let's generate a key pair. So we use generate key pair command. Like I said before, we're running it locally, so we're going to pass a TLS disable flag for the moment. Additionally, we're going to give it an ID for the beacon. If you don't pass this, there's a default ID default, which can be used, but just for excitement, we'll create one now. And so that I can almost certainly forget to put it in a bunch of different steps, and we'll see how it all feels. Okay, so we've got an ID walkthrough. Let's also pass a scheme. I was going to say the latest and greatest is BLS Unchained on G1, but in fact, there is an even later and greater scheme, but it's got a long number at the end I've forgotten. So let's use BLS Unchained on G1. And then finally, we need to pass this address other nodes are going to contact us via. For this example, and for simplicity, let's make it localhost 8081 because it's going to be node 1. And oh, in fact, we also need to pass a folder, which in this case can be client 1, because I want to separate all the different configs for the different daemons. Another important gotcha when running the CLI commands, when they have a value, in this case, localhost 8081, i.e. something that's not a flag, it's important not to put any flags after it. My not phase CLI, unfortunately, does not handle that case. And there's an issue in the GitHub, which is, gets necroed occasionally. It can cause surprising things without errors occasionally when you put flags after it. We've had, for example, people generate key pairs, but put their scheme afterwards, and it's been the wrong scheme, and fires everywhere. Okay, so God willing, I will put in the right incantations, and we will generate a key pair. Okay, wonderful. We can see our key pair has been created without TLS. It saves it here in a client 1 directory, plus some extra bits that we'll look at later. And everything else is correct. drand actually supports loading on a daemon that's currently running, but that's the next step in the process, so we're not going to do that just yet. Let's make this also the right size. Okay, so we're going to do this again, generate key pair. We're going to disable TLS on it, and we are going to put folder client 2 this time. I'm going to make sure we get the right scheme, or else bad things happen. BLS Unchained on G1. I feel like I've forgotten a flag, but that is okay, right? Okay, all good. Of course, the ID flag that I predicted I would forget at every step. You followed the first hurdle. And okay, then this one is going to be localhost 8082 because it's node 2. Yeah, all looks good and good. And we get a similar looking message for the last one. Wonderful. And for brevity, I'm going to copy past this and paste it in here. Complete with line breaks, of course. Let's set it to client 3, and it is going to be on localhost 8083. Okay, wonderful. We've generated our key pairs. Like I said, they're the kind of core primitive for everything drand related. Side note, they're BLS 12381. Well, it's a scheme we use for creating beacons that will come to that in a later code walkthrough session. Okay, so back to the presentation. A quick note on starting the daemon. I mentioned already that in the key pair generation, we need to provide some endpoint which we want other network nodes to contact us via over gRPC. That is a private listening address. Some people want to have a public listening address as well, so that people in the wider internet can get drand randomness from your node. As I said before, the standard way to do that is to run a relay and or a reverse proxy, but it is possible to do it from the daemon directly, and your relay may listen or contact your daemon on the public listen address also. And we'll see exactly how it looks in just a moment. Okay. So we've got our key pair. Fabulous. Now we're going to run the start command. As I said before, important to pass a TLS disable flag here, even if you are using TLS in production, handle TLS elsewhere. I can't stress that enough. We also want to provide a control port. One is set by default, but because we're running 3 nodes in one machine, it's going to be useful to have separate control ports for each of them. Additionally, I think we have to pass the folder here as well, if I remember correctly, which is going to be client 1 in this case. We're going to pass the private listen address, which is the one that we used when generating our key pair. Seeing as node 1 will also provide a listening address, which will make localhost 9081, again for simplicity. Okay, do I need any other flags there? Well, let's check the code base. I'm pretty sure that's it, but you know, in the heat of the moment, I might have forgotten some important ones. As you can see, the start command supports an absolute bucket load of different flags. Some of the old ones for running TLS in the node, don't do it, don't hurt yourself like that. A verbose flag, obviously for running this production and you want to get good logs, definitely worth having. There are a couple of other flags that don't really get used anymore. You can skip validation of your beacons, don't advise it. Also, drand daemons support different types of storage, which we're not going to go into today. There's another walkthrough on that, I think, walkthrough 6 or 7, something like that. There's also a metrics flag. There's going to be a session on that, so we're going to leave it out for now. Okay, it looks like I've remembered all the flags, but of course, the moment of truth is actually running it and finding out. Okay, wonderful. Let's look here. So we can see it started, it's insecure, control port's been set, it's listening in the right location. We've got this message saying beacon ID walkthrough, i.e. the one we created a key pair for, will run as fresh install, which it is, great. Expect to run DKG. That's a distributed key generation process we talked about before. That's obviously expected and wonderful. Okay, so let's run the same command here, more or less, on our second node, passing all the right bits and bobs. We'll leave out the public listen address for this one because it doesn't matter. We don't need it. Okay, and we see more or less the same message here, which is wonderful. And let's copy paste it over here and fill in the right places. Okay, it looks good to me. Okay, great. So we now have a running drand daemon, running network, you might say, although the nodes are not yet networked. So let's get to that bit. So distributed key generation, essentially what happens is the nodes sign a bunch of stuff, send all those bits of stuff to one another and aggregate them together, and then come up with a private key that nobody has access to, but everybody has a little share of. They can then use these shares to create randomness by signing messages every epoch as a group. So if we have n nodes and we set some threshold t, which normally is half n plus 1, i.e. 51% of the network need to work together to create randomness. That's essentially how drand works. They sign a message as a group. Because nobody has access to private key, nobody can figure out what the number is going to be. So distributed key generation starts by one node designating itself leader and starting the process. So how does that happen? Some node operator opens a CLI and they send a message to their own daemon to start the DKG as a leader. So let's do that. We'll pick node 1 to be the leader. Seems reasonable. Come on, I turned nothing. Okay, so we're going to do drand share. Point to note, there's currently a pull request, in fact, many pull requests up for a refactored DKG, which is going to change the CLI for this DKG quite a bit, although making it simpler. So to that end, this is a very short-lived tutorial on how to use the share command because it's going to die soon, and that's what the people want. Okay, so we're going to have to pass our control port flag again, which is going to be 8881 for our first node. We have to pass the beacon ID, which I've fabulously remembered. It's going to be 1 through. Because we want this node to be the leader, we have to pass the leader flag, unsurprisingly. Then there's a whole host of other flags that we need to remember in order to define some characteristics of the network that we're going to set up. So the first one is period. That's basically the amount of time between each epoch. So let's pick 3 seconds because, you know, in honor of fastnet, which runs a mainnet at 3 seconds. We also define a catch-up period. This is basically if the network gets behind, i.e., let's say a threshold number of nodes go down and the network stops creating randomness. In the case of, for example, Filecoin, if the network came online and suddenly caught up 1,000 beacons at once, the Filecoin network would be in a little bit of trouble. It would be too fast to mine 1,000 blocks that quickly. So we can define some period that's lower than the beacon period to catch up in case things are behind. We need to find a scheme. Of course, it is already there on the key pair, but in case people have generated their key pair wrong, it's good for validation that we pass the scheme in here. Some other things that we need to define are the nodes, the count of nodes we expect to participate in this DKG, which is going to be 3. Also the threshold. As I said before, generally we do n divided by 2 plus 1, but hypothetically you could use any threshold, but we're going to use 2 for this. And have I forgotten any flags? I have forgotten one flag. So for security purposes, we require members to pass in a secret in order to take part in DKG. I have, in Blue Peter style, here's one I made earlier, got a secret file containing a very secret secret, which I'm going to pass argument here, and all the nodes are going to share that because it's convenient. So if I put in the right incantations, we should see the DKG start on the leader. Okay, fantastic. We can see here in this not very well formatted text that the leader has started DKG. It is the leader, it's got the right scheme, and it's set up a manager. So essentially, whenever you issue this command to your drand daemon, it sets up a bunch of different objects within its memory, which it's going to use into process different packets from other DKG participants. Important point to note here, don't restart your daemon. That will nuke all that lovely state that the command has just set up. So not so important for the leader because the leader can just restart the DKG. But if another participant here were to join the DKG and then restart their node, they would get left out. So that's bad. Don't restart your node. Okay, let's have a little bit of a look at what the other participants are going to do when they join the DKG. So the leader started DKG. They set up a little bit of state on their node for running it. The other node operators now are going to jump on their CLI, and they're going to say to their daemon, connect to the leader starting a DKG. The daemon then is going to send their public key to the leader, basically signaling, I want to take part, here's my key, I'm going to sign all my messages as part of the DKG, henceforth with this key. Then what happens, and we'll not run it just yet because all flash to bang happens in milliseconds. What happens is when the leader receives all the keys, i.e. a number of keys that corresponds with that nodes parameter that we passed in, the leader will send the list of people participating in the DKG to all the nodes in the network and say, I've received all the keys now, let's start the DKG. So it's important at this phase that everybody has connection to the leader. These other daemons don't necessarily need to have connection to one another, as the DKG is a gossip protocol and everyone sends every packet they receive to everybody else, which is depicted in this lovely slide here. At the end of the DKG, everyone will have got all their shares, aggregated them together, got a new key share, represents the private key of the public group, or at least a portion of it, and a group file, which denotes all the people that have successfully completed the DKG, and each person's daemon will then store that in their flat file DB. Okay, so let's jump back over to our little network here and complete the DKG, hopefully. So the other nodes, let me make it bigger, are going to run a share command. Of course, they're not leaders, so they're not going to pass the leader flag this time. Did I need the TLS disable flag in the other one? I guess we're going to find out. Pass TLS disable. Let us pass the connect flags. Let's say who is the leader? Where can I find them? In this case, it is localhost 881. Also need to pass our control port for this node. And additionally, the secret file. And theoretically, everything should now, we should see our node 2 here join the DKG. Of course, we have to pass the beacon ID also. Walk through in this case. Okay, fabulous. Our second node is now participating in the DKG. Let's run a command on final node. And it's 3 secret file, and ID. Okay, cool. So when I hit this, it's all going to happen very fast. The nodes are going to proceed to DKG, gospel a whole bunch of packets. Hopefully, all be successful. Get the group file at the end and all be included in the group file. And then after a short cool-off period, we'll see them start creating beacons. And there we go. Boom. I told you it'd be fast. Each node then outputs the CLI, the group file that they have created at the end of the DKG. So we can see stuff like the threshold we set, the period we set, a time that the network should start creating beacons at. Genesee, not important for now, the scheme, obviously, and the ID that we set earlier. And then a list here of all the nodes in the network and what their public keys are, and whether you use TLS and where you can find them. Those are then used by the beacons, by the networks to send packets to create beacons, which we can see happening up here. Lovely, lovely new beacons stored, lots of different rounds. Because we have a public listening port on the first node, we can actually curl localhost 9081 public latest, and we should get, of course, there's no default hash, so we need to go and find the chain hash here. How inconvenient. It should be the group file, I think. Okay, well, it's not, so we can find the chains first. A quick demo in the how to use the APIs. Just chains, it is. Okay, so we've got a chain hash here. Close to 981 public slash chain hash slash public slash latest. We should see some randomness, hopefully. Woohoo, round 20. Okay, that was just created. Perfect. Here's our randomness. Here's our signature, which was used to derive the randomness. And if this were a chain network, we would also see a previous signature, but we've used one of the more hip, cool schemes, so that is not the case. Okay, we've now created key pairs. We've started some daemons. We set up a network. What's next? Well, next on the list is a bunch of different utilities you can use to interact with the drand daemon and see stuff about its health. The first useful one is status command. Essentially, the daemon sends a ping to other daemons in the network, waits for the pong, and you can tell things about connectivity and network from this. Super simple. We pass drand util status. We pass our control port in, and I think that should be everything. Do I need to pass parameters? Oh, of course, the ID of the network, which was walked through. Okay, and here we can see a little bit of information about our node. So the DKG has been done. We haven't done a reshare, which we're not going to get into today, but it's more or less the same as a DKG, except you add a transition flag everywhere. process of doing a reshare is slightly different to an initial DKG, as entropy only enters the network at the first DKG. In fact, all randomness beacons until the end of time are decided at that moment. So the resharing process is basically taking that key that already exists, chopping it up and resharing it amongst people without ever giving that private key to anyone in the network. So we haven't done a reshare, unsurprising. Some details about our chain store, the beacon process, and then also the network visibility. So we can see here our node 1 can see node 3 and node 2, all good. Just before I dive into the next status command, let's look a little bit at the layout of the drand directory, demystify it for any LOE members who maybe already have one. Okay, so if we look in the client 1's drand directory, we see first thing is a multi-beacon directory. Under this, if we have multiple beacons, we have a directory for each one denoted by its beacon ID. We've only got one, walkthrough. So we see a directory for walkthrough. Under that walkthrough directory, we see 3 more directories, DB, groups, and key. The drand DB contains any of the beacons that have been created by the network. If you were to start a drand daemon and join a new network, you would have to either regenerate the beacons, or not regenerate, rather sync all the beacons since the dawn of time, or copy pasta a drand DB from somebody else and put it in this folder. In the groups part is everything to do with the DKG. So we've got this distributed key, which was created in that DKG process. This is our portion of the private key. And the group file, which is what got spat out here from our DKG at the end, and is used then to contact other nodes. And in our key directory, we have our public key and our private key. That was what we generated in the generate key pair command. If you're running a node, for instance, in Docker, important to have this in a volume somewhere that doesn't get nuked if your Docker host restarts. Also, similarly important to keep it safe. If somebody gets your private key, you're in big trouble. Okay, so back to some of the other useful utility commands. We've also got a remote status command. This is quite similar to the status command, except that rather than getting your daemon's view of the network, you're contacting another daemon and saying, hey, ping everybody else and tell me what your view of the network is. This is quite useful for debugging connection issues between different parties in the live network. For example, some people may not have updated their allow list and might not have connectivity to some nodes. Some geographic restrictions, such as China, might not enable their nodes to connect to nodes from different countries, for example. That's something we've seen in our live network. So this is useful for debugging any issues where some people can't talk to other people. And it's very similar to the status command. We just do drand remote status. Again, we pass the ID walkthrough. We pass our control port 8881. Unlike the other command, we can pass a list of nodes here that we wish to contact to see their view of the world. So let's pass our second node's URL. And we can see, similarly, it has done a DKG, no surprises there. It's up to date with the latest round. And network visibility-wise, you can see node 1, node 3. Again, no surprises. If, for instance, they couldn't see it, let's take down a node because, you know, let's do it live and all that. We would see node 2 has no connection to node 3. Because our threshold was 2, still aggregating beacons here, so we're all good. We can restart node 3 and it will probably start doing a catch-up process, which is wonderful and expected. Great, great. Okay, let's look at my little list here of other stuff. That is all the important stuff. Another interesting command, which may or may not be useful, but if you're setting up new nodes, you can also do a backup. So you can back up a database to another file you want to use. I've completely forgotten what the command is. Okay, oops. drand util backup, of course. With the pass control port in here, 8881. And I think argument then is where you want, well, our beacon ID, of course, as well. I think then we can pass a place where we want the backup to live. No, that was untrue. Told you all lies. Here's one I made earlier. Out, okay. Indeed. So we pass the out flag and we should see, there we go. We've got a backup dot back, and that contains all the beacons that we created. So if you have multiple nodes, you can copy them between nodes and restore your state without having to do a laborious syncing process. So that is the whistle-stop tour of using the drand daemon. I think we're more or less on time. I'll take some Q&A, and if there's still some time after the Q&A, then we can go back and look at client libraries and Docker. Oh, well, I suppose stopping a daemon as well. I mean, obviously you can just kill it here, but you can also stop individual beacons. If you have multiple beacons running a network, for example, and maybe your node got left out or doesn't want to run one anymore because it's too expensive, you can just pass the control port and the ID, and it will stop that beacon, but does not stop the node. We should see down here that the node is still running, but the beacon handler has been stopped. And with that, I will open myself up to questions from anyone who has them. I see there's many chat messages, so let's look through these. Blah 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 blah. I would just turn off videos. So yeah, okay. That screen flex. Yeah, I've got a Gucci screen. You better believe it. Curve and all sorts. Wow. Font size small. Yes. Sorry. Hopefully it was okay for the majority of it. You can use yes. Don't forget the folder flag. Yes. Bye bye, Yanis. Control flag doing the drand start command. Okay. Johan's answered that. Wonderful. Members of the network, yeah, that's been answered. Okay, cool. All the questions in chat answered. Wonderful. Has anybody got any live questions? Hold on, I need to get my tumbleweed here just so I can. I must have explained everything so perfectly that you all understood it. Or at least that's what I'll tell myself. Okay, well, let's look quickly into the client libraries then. We offer at the moment 2 official client libraries and 1 unofficial client library. One of the official ones lives in the drand codebase here. Let's see if we can look at a test on how to use it. Client test, you do it. It's actually a little bit hard to use. It's kind of old and had some certain ideas in mind where you wrap multiple clients. In Lotus nodes, people bundle a bunch of clients together and speed test them constantly, which is something that we do out of the box here. I think this optimizing client here allows you to, for example, pass clients of different protocols. So for example, a libpdp client, an HTTP client. Maybe you've created your own magical protocol and you want to serve beacons on that. It's entirely possible. This optimizing client will constantly speed test the different clients to see who has the best latency to, and then use that one. You can install it in Go. One of the lovely things about it is you can install a module within another repository. So you can just go get drand/client and use it in your code base straight away. I think the best way to figure out how to use it is to go into the tests here and try it yourself. Additionally, we also support a JavaScript client written in TypeScript, which is here. I think there's some lovely examples, yes, and how to use it here in the README. So I'll not go too deep into it, but we've got a couple of these functions you pass some big set of options to, and the magic happens. There's also an unofficial Rust client, although it does not support the newest schemes just yet. drand client RS. So yeah, there's still a little bit to do here. Maybe a better option for the drand nerds out there is using a tool called D from one of our partners in Cloudflare, Thibault. I can never remember the name, drand RS. It's actually a CLI for interacting with the drand network. It acts as a client, and you can also do time lock encryption and decryption with it, which is very cool. For those of you who haven't time lock encrypted anything, why not? Get it done. Yeah, it's super easy to use. This is what I use now rather than our client locally, because it's just a little bit nicer, basically. As for Docker, we have a Docker folder here that contains fairly in-depth details on. Oh, this preview doesn't work. Let's look at it in GitHub then. Fairly in-depth details on how to use it. There's a couple of out-of-the-box Docker Compose files for spinning up a network, also spinning up a node with Nginx. It's important to take note of the Nginx config. We had a few partners misconfigure Nginx and have some issues when running the DKG, because gRPC and HTTP don't play so nicely. So important to check out the Nginx config in there to get all the right stuff. Another important point to note with Docker, I mentioned it already. Ooh, this is out of date. Is to have a separate volume, probably an external volume for your keys, lest they get nuked whenever you take it down with the -v flag. We've all done it. Not in production, luckily. So that's an important point to note. There are a couple of scripts in here for doing all that stuff. If you need to, like, generate a key pair and such. So get stuck in. Some just final housekeeping notes on using drand. I mentioned you can pull a repo and make install yourself. You can also download the releases here on GitHub and historical releases if you want to try and figure out some of our bugs that we fixed in the past and how it worked. We also, as of quite recently, package our Docker images on GitHub package container registry. I think that's what it's called. Previously, we were on Docker Hub, but then they did that whole thing with trying to get rid of free accounts and such. So we moved everything to GitHub, and it's all on there now. So you can find our Docker images there. Yeah, that's everything from me. For people who want to get involved, we have many issues in the backlog. Some of which are tagged with good first issue, I think, somewhere. Yeah, here's one. So the best way to learn is to get stuck in. Obviously, we're all available on our Slack channel, which you can find the invite to on the drand.live website down at the bottom here somewhere. Yes, here. Similarly, you can tweet us, you can blue sky us, or reach out to us on Filecoin Slack. There's also a drand channel on Filecoin Slack. Let's check any other messages here. We can find a recording. The recording will be somewhere, I'm sure, and we'll post about it in the drand Slack when we have it. Are there any final questions, thoughts, feedback, concerns, comments? Well, with that, I will stop sharing, and thank you very much, everybody, for joining the first code walkthrough. Again, next one is going to be in 2 weeks. Again on Tuesday, again at the same time. The topic is going to be, what is a drand beacon? How is it created? Important questions that you ought to know the answer to if you want to get involved. So thank you very much. With that, I will stop the recording. So if you have any insults you want to hurl, you can do it now.